measurable properties of gases. What are all the different measurable properties of gases? To define a gas. To define a gas, the measurable properties what we require are, first of all, for any substance, what is the amount of substance, that is what we have to define. How much is the amount of substance what we took. So, that is for the amount of substance to define, what we have is, one is mass of the gas and moles. Mass, as all of you know, here I need not to define anything. Mass we take it is in terms of grams or kilograms, and moles is equal to weight of the gas by gram molecular weight of the gas. Okay. So, this is what we take, this is all of us know. Then pressure. Pressure is again a parameter which also dependent on the amount of gas. Pressure is defined as a force exerted by gas molecules per unit area. Okay. Force per pressure is equal to force per unit area. So, it is defined as the force Newton per meter square or dynes per square centimeter, and it also has certain units Pascal, and it also has a units bar. It also has a unit in terms of height of the mercury column. In terms of height of mercury column, we measure it in terms of millimeters of mercury, height of mercury, or centimeters of mercury column, according to which now we have different relations that or 1 atmosphere. In chemistry generally we take it this in terms of the height of mercury column, but it is not necessary that always it should be given only like that. First it will be, if it is given like this, then even we can convert one into the other. 1 atmosphere is equal to 760 mm of mercury, which is equal to 76 centimeters of mercury column, and which is equal to 760 bar, means 1 mm of mercury is equal to 1 bar, and again this is equal to 1.01325 into 10 power 5 Pascal or 101.325 kilopascal, right. This is how we can convert one to the other. This is about the pressure. So, it is, the pressure is nothing but force exerted by gas molecules per unit area on the vessel in which it is taken, and so it is the different units, and it is usually measured in terms of height of mercury column, right, in an atmosphere. So, that is what we measure. These are the relations. One atmosphere is 760 mm of mercury column, 76 centimeters or 760 bar, or it is 101.325 kilopascal. These are the units in which the pressure is measured. The next is the volume and temperature. These are the other two parameters which we have to define for gas. The next is regarding volume of gas. Volume of gas is nothing but the overall space occupied by given amount of gas, the overall space occupied by given amount of gas, that we measure it in terms of liter, milliliter, and also cubic centimeter, cubic meter. These are the different volume, because volume is nothing but, suppose if you take a cube, to a cube volume is nothing but, to a cubic vessel volume is nothing but cube of the edge length. So, edge length is the length units centimeter or meter. So, cube of it is cubic centimeter or cubic millimeter or cubic meter, anything that what we get. And of course, this is well known that 1 liter is equal to 1000 ml, 1 ml is equal to 1 cubic centimeter, and 1 cubic meter is equal to 1000 cubic centimeters. So, this is a conversion from of one unit to the other. Then the next measurable property what we will have is temperature. Temperature is a parameter which is something different from the previous things that what we did. The temperature is a parameter by which we can understand, it is a parameter from which we can understand how energetic are the gas molecules. How energetic are the gas molecules, that we can define, that we can understand from the term, from the parameter called temperature. Okay. And temperature is also, it is a measure of change in heat content. It is also a measure of change in heat content of a system. This to measure, that means, as we know, when we thermometer is what we use to measure the temperature. When we feel hot or whenever we have a fever, when our body gets heated up, then temperature increases. So, how much heat is increased to know, we measure that in terms of temperature by using that thermometer scale. The thermometer scale, that is the temperature, is measured in different units, but mainly what we are interested is in degree Celsius, degree Celsius and Kelvin scale. There are also certain other things, Fahrenheit, Ramer and all, but now we are not using them at all, except in those thermometers which are used to measure the fever, that is medical thermometers. Except in medical thermometers, for any chemical applications, chemical uses, we are not using those thermometers of Fahrenheit. So, no need of that, but degree Celsius and Kelvin are the two things that what we require. In the degree Celsius and Kelvin, T degree Celsius is equal to T plus 273 Kelvin. This is the relation, right. So, this is the, normally it will be given in degree Celsius, and but all the gas laws and all which we define and all the numerical problems what we solve based on the gas laws or any other calculations made in this gaseous state, always we take this Kelvin scale into consideration only. So, if at all the temperature is given in degree Celsius, then definitely it has to be converted to Kelvin, and then we have to go for solving the problem. So, these are the basic for mass, pressure, volume, temperature. These are the 4 fundamental parameters required to define a gas. Okay.